In this video, we want to take a look at what I call the power reducing formulas. Sometimes they're called the half angle formulas. We have other things that we call half angle formulas. They are, however, very, very closely related. So here we go. I'm going to start with the double angle formula for cosine. So I'm going to start with the cosine of 2 theta. I can usually only remember the vanilla flavor here. So cosine squared of theta minus sine squared of theta. I can then change it, so I'm gonna change it to the strawberry flavor here. So I'm going to take the cosine squared theta and write it as 1 minus sine squared theta. Minus sine squared theta. There we go. And so those get together, and I've got 1 minus 2 sine squared theta. Okay. So the cosine of 2 theta is equal to this. I might have been able to just write that down if I could remember it, but I can never remember which one has the 2 something squared minus 1 and which is 1 minus. I can never remember. But that's fine. I can get it every time. What I want to do now is I just want to solve for sine squared. So what I'm going to do is I'm going to add the 2 sine squared over to the other side, 2 sine squared theta, plus cosine 2 theta equals 1, and then we'll subtract this over there. So 2 sine squared theta equals 1 minus the cosine of 2 theta. And then let's divide by 2. So I've got that sine squared theta equals 1 minus the cosine of 2 theta all over 2. This is what I would call a power reducing formula. The power of the trig function here is 2. You got a trig function squared. Here you just have a trig function to the first power. You did double the angle, right? This is a theta, this is 2 theta, but that's okay. We have another relationship here. That sine squared can be written as 1 minus the cosine of 2 theta divided by 2. Notice, this is just the double angle formula for cosine, strawberry flavor, solved for sine squared. Power reducing formula number 1. Okay, power reducing formula number 2. What we're going to do is we're going to start all over again with the cosine of 2 theta. This time I'm going to take the chocolate flavor, and having already done both of those, I can see that the chocolate flavor is going to look like this. 2 cosine 2 theta minus 1. No. What am I doing? 2 cosine squared theta minus 1. That's the chocolate flavor. And I just want to solve for cosine squared. So let me add the 1 to the other side. So 1 plus the cosine of 2 theta equals 2 cosine squared theta. And then divide by 2. Divide by 2. And I'm going to write this on this side. Cosine squared theta is that stuff. 1 plus the cosine of 2 theta divided by 2. And there is your second power reducing formula. You go from a cosine squared to just a cosine to the first power. In the meantime, the angle doubles. You go from theta to 2 theta. Okay. Notice these are very closely related. The only difference is there's a minus sign here and a plus sign there. Well, they should be closely related. They came from the same place. They came from the double angle formula for cosine. Strawberry flavor, chocolate flavor. Okay. One more power reducing formula that we'll put up here for your viewing pleasure. Tangent. And really, if I look at tangent squared theta, I think of this as sine squared theta over cosine squared theta. Generally, whenever I can change the sines and cosines, I do. So there's that. Well, I know sine squared theta is this thing, right? This is 1 minus the cosine of 2 theta divided by 2. And the cosine squared theta on the bottom is 1 plus the cosine of 2 theta divided by 2. And when I invert and multiply with that fraction there, the 1 minus the cosine of 2 theta ends up, stays on the top. The 2's cancel out, and the 1 plus the cosine of 2 theta ends up on the bottom. So there is a power reducing formula for the cosine, for the tangent. I should point out that this is often not written like this because a curious thing happens here. You can write it like this. Pause for a moment here. The double angle formula for cosine, I had 3 different versions of it. The power reducing formula for tangent ends up with 3 different versions too. This is one of them. This is the one that comes straight out of sine divided by cosine, right? Putting those things in there. Then I can manipulate it a little bit and get some other ones. So let's see what else I can get here. What I want to do is I want to multiply by 1. So I've got, just write the fraction down again here, 1 plus cosine 2 theta. I'm going to multiply by 1 in the form of, it doesn't matter, or I'm going to use the numerator here, 1 minus the cosine 2 theta on the top, and the same thing, 1 minus the cosine of 2 theta on the bottom. I'm multiplying by 1. I'm not changing the value. I'm just changing the way it looks. All right. The numerator I just want to write as 1 minus the cosine of 2 theta, the whole thing squared. The bottom I want to FOIL it out, though, because I can see something nice happening. There's a 1. The outsides are minus cosine 2 theta. The insides give you plus cosine 2 theta. Those cancel out. And then the last give you minus cosine squared 2 theta. And that denominator, 1 minus cosine squared 2 theta, is just sine squared theta. So I've got this thing on the top here, that's just being left alone. And then I've got a sine squared 2 theta on the bottom. So there's my second version of the power reducing formula for tangent. In some ways it's unsatisfactory because you're not really reducing the power. You got sine squareds here again. That's all right. When we switch to the half angle formulas, this is going to be a convenient form to have it in. This is the one up here where you really have cosine to the first powers, so the power has been reduced. Okay. One more thing I want to do is I want to go back to, actually I'm going to see if I can do this over here. I'm going to do a separate calculation in red. Okay. So I'm going to do a separate calculation in red. So where here I multiplied by 1 like that, this time instead of multiplying by this fraction, I want to multiply by this fraction. So I'm thinking of this fraction here times that one over there. Okay. So this time in the denominator I just have the perfect square. So the denominator here is 1 plus the cosine of 2 theta, the whole thing squared. The numerator now is the one I'm going to multiply out, FOIL it out here. I've got 1. The outside terms give me a plus 2 cos theta. No, they give me a plus cos 2 theta. The inside terms give me a minus cos 2 theta. Those cancel out, and then I'm left with a minus cosine squared 2 theta, which turns into a sine squared theta on the top. So I've got sine squared theta. No, it isn't. It's sine squared 2 theta on the top. And it's a 1 plus the cosine of 2 theta, the whole thing squared on the bottom. So this would be the other double angle formula. No. What do we call it? Power reducing formula for tangent in terms of sine and cosine here. They look a lot alike. This one has sine on the top, sine on the bottom. This one has the cosine. Oh, this has got a plus sign instead of a minus sign. They're similar, but different. They happen to be equal to each other, okay, because they're both equal to tangent squared theta. There you go. There's your power reducing formulas. Next, we're going to turn these things into half angle formulas.